in today's lecture we will look into chloroform, right? Chloroform, which is it's a haloalkane. The formula is your CHCl3, right? Now, since it contains more than one halogen atom, till this time mostly people are aware of haloalkanes like CH3Cl, C2H5Cl, right? All these contains one halogen atom. Now, chloroform, which is also a haloalkane, contains 3 halogen atoms, right? So compounds that contain more than one halogen atom are called as your polyhalogen compounds, right? So chloroform is a polyhalogen compound. We'll be looking into its preparation, its chemical properties and its uses quickly, right? So for the lab preparation, right, in the lab, chloroform can be prepared by treating your ethanol or acetone with bleaching powder, right? You take a paste of bleaching powder and you mix it with chloroform. You take a paste of bleaching powder and you mix it with ethanol, right, which is C2H5OH, or your acetone, right, which is also known as propanol, right? The other name for acetone is propanol. Formula is this, your CH3COCH3, right? So first let's look into, this is your acetone. So let's look into the steps, right? All the steps that takes place when your ethanol reacts with bleaching powder to form chloroform, right? So here, treating ethanol or propanol with bleaching powder. What is bleaching powder? Basically, bleaching powder is your calcium oxychloride, right? This is the formula of bleaching powder, CaOCl2, right? CaOCl2 is your bleaching powder. It is calcium oxychloride. So when you take a paste of bleaching powder and you treat it with your ethanol, the first reaction that takes place is your bleaching powder will react with water to give you chlorine and calcium hydroxide, right? Now the important thing to understand here is that this chlorine can act as your oxidizing agent as well as your halogenating agent. This is an important step, or that the thing that you need to remember about regarding chlorine, right, if you want to understand this reaction. So chlorine, which is produced here as a result of reaction between bleaching powder and water, right? So this chlorine, right, will further react to form chloroform. Like now let's see. Second step would be, since we have mixed ethanol and bleaching powder, right? Bleaching powder will react with water to give chlorine. Now chlorine will react with your ethanol, right, and will first oxidize it. Since it can oxidize, since it acts as an oxidizing agent and halogenating agent, so it will oxidize your ethanol to form acetaldehyde, right? When we say oxidize, that means it will remove hydrogen, right? So you can see 2 hydrogens are removed from ethanol, it will form acetaldehyde. So in the first step, chlorine acts as an oxidizing agent. This is an oxidation reaction and will oxidize ethanol into acetaldehyde. Now acetaldehyde will further react with chlorine, right? Further react with chlorine to form chloral, right? It will react with chlorine, chlorine will react with acetaldehyde and will replace its hydrogen atoms, right? I'll just show you. It's like this. This is your CH3CHO, right? Chlorine will react with acetaldehyde, right? Will replace all these 3 hydrogen atoms to form CCl3CHO. This is the compound. We call this as trichloroacetaldehyde or your chloral, right? Now chloral will react with calcium hydroxide. From where we got calcium hydroxide? From here, in the first step. It will react with calcium hydroxide to form chloroform, right? And the other product is your calcium formate, right? So just remember, your last step is your chloral, which is produced in the second step as a result of reaction between acetaldehyde and chlorine. Acetaldehyde is formed as a result of oxidation of ethanol with chlorine, right? This chloral will hydrolyze with calcium hydroxide to give you chloroform, right? So this way you will prepare chloroform. Now looking into the second method where you can prepare chloroform with acetone by reaction between acetone and your bleaching powder. Bleaching powder is calcium oxychloride, right? First step would be same. Your bleaching powder will react with water to give you chlorine, right? Then chlorine will react with acetone, right? And it will chlorinate all the 3 hydrogen atoms of one of the methyl group of acetone to give you trichloroacetone, right? CCl3. Here you can see all these 3 hydrogen atoms of methyl group are chlorinated, right, to form trichloroacetone. Right? Now this trichloroacetone, when fused with or when hydrolyzed with calcium hydroxide, right, will form your chloroform. Right? Calcium hydroxide has come from the first reaction. Right? I hope this is clear. The important thing to remember is the chlorine that is produced in the first step will act as oxidizing agent and as a chlorinating agent. Right? Here it chlorinated it to form trichloroacetone. Right? Then trichloroacetone will react with calcium hydroxide to give you chloroform. Right? I hope this is clear. Now out of these 2 methods, second one is most preferred, that is formation of chloroform by reaction between bleaching powder and acetone. Why? Because yield is better, right? Better production of chloroform is resulted from the second reaction, that is reaction between acetone and your calcium oxychloride, which is bleaching powder. That is why your reaction with acetone is preferred because of better yield, right? Now let's look into the another lab preparation using sodium oxychloride. Using sodium oxychloride, or we call it as sodium hypochlorite. Right? Sodium hypochlorite will also chlorinate acetone. Right? What we will do is we'll treat acetone with sodium hypochlorite, right? Alkaline sodium hypochlorite. Whereas in the first step, your sodium hypochlorite is obtained by reaction between chlorine and sodium hydroxide, right, to form sodium hypochlorite. Now this sodium hypochlorite will react with your acetone, right? What it is doing is it will chlorinate your one of the methyl groups of acetone to form this CCl3. This is your CCl3, right? So this is your trichloroacetone, same as here, right? So this is your trichloroacetone, which will further react with sodium hydroxide, right, to form your chloroform. Right? I hope this is clear. This is your sodium hypochlorite, preparation from sodium hypochlorite. So sodium hypochlorite produced as a result of reaction between sodium hydroxide and chlorine will chlorinate acetone to give you chloral. Chloral will get hydrolyzed with sodium hydroxide to give you chloroform. Right? I hope this is clear. Now looking into the manufacture of chloroform on large scale. Right? On large scale, you prepare it by chlorination of methane. Right? Methane reacts with chlorine in the presence of sunlight, right, or heat to form methyl chloride. You can see this. To form this chloroform, CH3Cl, right? And the other products that you see is CH2Cl2, CH3Cl, and CCl4. That is all hydrogen atoms of your methane, right, will react with chlorine, right, to give you different products. You will get polysubstituted products here, right? These are polysubstituted. You can see in the first product, one atom of hydrogen is substituted with chlorine. In the second, 2 hydrogen atoms are substituted with chlorine. In the third, 3 hydrogen atoms are substituted with your chlorine. Right? This is your CHCl3. And in the fourth, CCl4, where all the 4 hydrogen atoms are substituted with chlorine to form carbon tetrachloride. Right? So this method is mainly used in industrial preparation of chloroform, because in industrial preparation what you will do is, since you've got these 4 products, right, polysubstituted products, now you need to separate this chloroform, right, out of these 4, right? You have to separate chloroform from rest of 3. What you will do is you will employ fractional distillation. Using fractional distillation in industries, the chloroform would be separated as one of the fractions. Right? So you will employ fractional distillation. Right? Fractional distillation to separate CHCl3, chloroform, from this mixture. Right? And there is one more thing about this reaction, that you can adjust the ratio of methane and chlorine, right, to give you only chloroform. Right? That is also one of the ways. Right? The other way is you take CCl4, right, carbon tetrachloride. This is another way for industrial preparation, where you prepare chloroform from carbon tetrachloride. What you will do is you will do partial reduction of CCl4 with iron, right, and steam. Right? In the presence of iron and steam, carbon tetrachloride will undergo partial reduction to form chlorine. When we say partial reduction, all Cls would not be replaced by hydrogen, only one of the Cl would be replaced by hydrogen to form chloroform. Right? So these are the ways to prepare chloroform. Right? There is one more way to prepare pure chloroform, right, where you will take this chloral hydrate. Right? You will take this chloral hydrate and heat it, you will get chloroform. Right? This is the product, chloral hydrate. Since you have 2H2O, so this is hydrated. So we call it as chloral hydrate. Right? Will give you, on dissociation, it will give you pure chloroform, CHCl3. Now let's look into the chemical properties of chloroform. One very important use of chloroform is as an anesthetic, right? But now the use of chloroform as an anesthetic has gone down. Why? Because the excess dose of chlorine might be toxic, right? And there are some other things also, that chloroform, if chloroform comes in contact with atmospheric air, right? When chloroform comes in contact with atmospheric air, it will react with oxygen of the air to form a poisonous gas phosgene, right? COCl2, this carbonyl chloride. This is a poisonous gas, right? So this is one of the disadvantage, that chloroform might come in contact with air and will form a poisonous gas phosgene, right? It might be dangerous. So that is why, if you see the chloroform bottle that is kept in labs, right, the chloroform bottles are, the chloroform is stored in dark bottles, dark brown bottles, right, so that because in dark brown bottles or almost black bottles, the liquid inside is saved from sunlight, right, and if chloroform comes in direct contact with sunlight, it will form your phosgene gas. Right? This reaction, if you look at this reaction, chloroform will react with atmospheric air, oxygen, in the presence of sunlight to give you this poisonous gas COCl2, phosgene. To prevent this reaction, chloroform is kept in dark brown bottles in the lab, right, and is tightly stoppered and filled up to the brim. It's filled till the top, right, so that there is no air above it, right, and is tightly stoppered so that air may not enter into those bottles. Right? And while packaging, when the chloroform is packaged in industries or in factories, what they do is they put little ethanol into chloroform. Why? Because if in case chloroform comes in contact with air, the phosgene gas that produced, right, this phosgene will react with ethanol to give you a non-poisonous product, which is diethyl carbonate. Because ethanol will react with phosgene gas in case it is produced, right, and will form a non-poisonous product, which is your diethyl carbonate. Right? This is important thing about chloroform. Now looking into other reactions of chloroform, the reduction reaction. Right, this is a reduction reaction. It has there are two reduction reactions. First is chloroform reacts with zinc and HCl to form dichloromethane. Right, you have two Cl2, two chlorine groups, this is dichloromethane, and if you take zinc dust and water, it will form methane. Right, in the second reaction you can see when you take zinc dust and water, all the chlorine atoms are replaced by hydrogen atoms, right? So you have methane here. Right, now if chloroform, the other reaction is reaction of chloroform and KOH. With KOH, chloroform will get hydrolyzed. All these three Cl groups would be replaced by OH groups, right? And it will form formic acid, which will further react with potassium hydroxide to form potassium formate. Now, important thing about this reaction is the one that we have studied in the very first lecture, that in case of, when we studied about classification, that in case of dihydric alcohols or trihydric alcohols, OH groups would not be connected to the same carbon atoms, because that would be an unstable compound and a water molecule would be eliminated from it to form a carboxylic compound, right? Carboxylic compound like an aldehyde, ketone or a carboxylic acid. So same situation is here. You have three OH groups, right? Here three Cl groups are replaced by OH groups, right? You can see. Now this is an unstable system because three OH groups are connected to the same carbon atom. So one water molecule would be removed from it and it will form a carboxylic acid, formic acid, which will further react with KOH to form potassium formate. Right? I hope this is clear. Now its reaction with chlorine, chlorination reaction, it will form CCl4 in presence of sunlight. With nitrous acid, it will form this addition product CCl3 dot NO2. This is the name of this. The name of this compound is your chloropicrin, right? And chloropicrin is an insecticide and a war gas. Right? The name of this, when chloroform reacts with nitrous acid, right? And when heated, it will form chloropicrin, right? And chloropicrin, we know, is used as an insecticide and a war gas. This is a gas which is used in war, right? Now, coming to very important reaction, this is we call it as Carbillamine reaction. So remember the name of this reaction, Carbillamine reaction, where chloroform reacts with aliphatic or aromatic amine. What is an amine? Amines are derivatives of ammonia, where one hydrogen atom or more than one hydrogen atom of ammonia is replaced by an alkyl group, right? So if you look at this is C6H5NH2. So here one hydrogen atom is replaced by this alkyl group, which is benzene, which is here benzyl, right? So this aromatic amine, right, C6H5NH2, right? This is your primary amine. This will react with chloroform. You can see this 2HCl would be removed, right, and C6H5N CHCl, right, this is remaining. So C6H5NC, this isocyanide will get formed, plus 3Cl, KCl and 3H2. Remember, this reaction is used as a test for aliphatic and aromatic amine. And how is it tested? That in this reaction, the product, this phenyl carbilamine or phenyl isocyanide that gets formed, it has a very bad smell, it has a foul smell, right? That tells you the presence of an amine, right? If you have an amine, if you treat it with chloroform, it will produce an unpleasant smelling compound, which is your phenyl carbilamine or phenyl isocyanide, right? This reaction is known as carbilamine reaction, which is used as a test for your aliphatic and aromatic amines, right? Phenyl carbilamine is formed. That's why we call it a carbilamine reaction, and it has a very unpleasant odor, right? So this is used as a test for aliphatic and aromatic amines. So now when chloroform is heated with silver, it will form your acetylene gas, right? This is a simple reaction. And when chloroform is treated with acetone in the presence of potassium hydroxide, it will form chloritone, a hypnotic drug. This is a drug which will help you to sleep, right? People who are suffering from sleep disorders, generally what they do is they take drugs that will induce sleep, right? So chloritone is one of the drug. It is a hypnotic drug. Hypnotic drugs are sleep inducing drugs, right? So this Chloroform will react with acetone in the presence of KOH to form chloritone. You can see in this product these two methyl groups are retained, right, and this entire CHCl3 is added here, right. OH, that is OH of chloroform, and O of acetone is OH, and the rest of the molecule CCl3 here. Right. This is kind of an addition product which is a chloritone, a hypnotic drug, a sleep inducing drug. Right. Then the other reaction, this is again an important reaction. We will be doing this lecture in a different lecture, this reaction in a different lecture. This reaction is known as Raymer-Tiemann reaction. This is again a very important reaction. Raymer and Tiemann are name of the scientists, right? Where this will be doing this reaction in detail under chloroform. We'll be looking into its mechanism also. Under phenol. When we study phenol, we'll be doing this reaction in detail along with mechanism. So phenol will react with chloroform with sodium hydroxide to form this ortho-hydroxybenzaldehyde. You can see this OH, due to this reaction in phenol, a CHO group, aldehyde group would be introduced at ortho position here. So this compound is named as ortho-hydroxybenzaldehyde, or we also call it as salicylaldehyde, right? This is very important reaction, Raymer-Tiemann reaction. Phenol will react with chloroform in presence of sodium hydroxide to give you ortho-hydroxybenzaldehyde, or we call it a ortho-hydroxybenzaldehyde or salicylaldehyde, right? Reaction, name of the reaction is your Raymer-Tiemann reaction, right? Just remember that a CHO group in Raymer-Tiemann reaction, a CHO group would be introduced at the ortho position of phenol ring, right? I hope all this is clear. In the next video lecture, we will look into the different compound iodoform. Thanks.